Dear students, today we are going to discuss from class 9 mathematics book chapter 6, that is lines and angles, part 1. Dear students, have a look around you. You can see many objects like wall, doors, windows, tables, almirahs. Can you see that its edges are straight edges? Now let's have a look at the junction where two walls meet. What is it? It forms a straight line. And the place where all such lines meet, that gives a tip or a point. Then from this discussion, it comes to our mind that these lines, planes, or your walls, surfaces, all consist of points. Then what is this point? This point is the basic unit of geometry, and it is undefined, means we cannot define a point. We also cannot define some other terms like plane, straight line, but the whole geometry subject is built on these undefined terms. Now today we are going to learn about some definitions, lines of angles, and intersecting lines and non-intersecting lines, and pairs of angles. So in this basic terms and definitions, what do we study today? Let's see. A part of a line or a portion of line with two endpoints is called a line segment. Have you ever come across with such line segment? In earlier classes in which you have asked to draw a line, what did you do? You put the tip of the pencil along the edge of the ruler. You started with some point and end at some point. Whatever till today you have drawn, that is line segment, because you are starting with a point and you are ending with a point. We can extend it on both sides indefinitely. So we can say this line you have drawn from a starting point to an end point, that gives a line segment, and the line segment AB is denoted by AB bar upon it. And a part of line with one end point is called a ray. That means if we start from a point along the ruler and go on drawing and drawing onwards infinitely, then we will get a ray. So in a plane on which we are dealing with is not so vast, so we have to represent the ray with an arrowhead in its one end, as it is seen in your screen. So the ray AB is denoted by AB with a arrowhead, single arrowhead upon it. Now what is a straight line then? A line AB means here the straight line. The straight line AB is denoted by AB with a double arrowhead upon it. What does it mean? It means if we take 2 points on AB and we go on drawing to both sides, both in the direction of A and in direction of B. If we stretch the line infinitely, then that will be a straight line. This shows that to represent it on the paper, we have to make two arrowheads on a line. This arrowheads indicates that they are extendable to both sides. Now, but when we study the subject geometry in our onwards, then what will use to denote these things? We will not use all these arrowheads or bars, and will denote the line segment AB, ray AB, length of the line AB, everything will write only AB without any mark, because in the context it will be understood what is it, whether it is dealing with the line AB or a line segment AB or a ray AB, or it is the length of AB. Okay? Then comes to angles. What is an angle? The angle is formed when two rays originate from the same endpoint. As we know, a ray has one endpoint and it extends infinitely. So, if two rays have a common origin or endpoint, then an angle is formed. In this figure, you can see OB is a ray and OA is another ray starting with the endpoint O. And in the next figure, you see QR is a ray with origin Q, and another ray with origin Q is QP, that forms the angle PQR. And in the next figure, we have the angle XYZ, where Y is the origin of two rays YZ and YX. So, when we consider these angles, we have to study about the naming of an angle. How to name it? When we name an angle, we can name it with a single letter. That is the, as you say, the common origin point. Let's have a look that the rays making an angle are called the arms of the angle. So, what is arm? Arm means, you see here the rays OA and OB are the arms of angle AOB. QR and QP are the arms of angle PQR. YZ and YX are the arms of angle XYZ. And the common point in all these things, as we denoted earlier, that the common vertex, that common point from which these rays are originated, is called the vertex of the angle. Now guess which are the vertices of these angles. It's in singular we can say vertex, and in plural sense we can say vertices. In the first angle, the vertex is O. In second angle, the vertex is Q, and in third angle, the vertex is Y. Now, let's come to naming of the angles. Now, here you see we can name the angle from their name of the vertices. For example, in the first case, we can say it is angle O. In second case, it is angle Q, and in third case, it is angle Y. But it is not always convenient to name the angle in one letter. So, usually we use 3 letters to express the angle. And how to write that? The vertex must be the middle letter of the name. That is when in first case the name of the angle is AOB. Why AOB? O is the vertex. You can write the name of this angle as AOB or BOA. But the vertex will not change. The other two may change, AOB or BOA, that represents the same angle. Similarly, PQR or RQP, that represent the same angle, but Q will not change its position. Similarly, while writing the name of the third one, that is XYZ or ZYX, Y is the vertex and this letter will come at the middle of the name. Okay? Then we'll learn about some specific angles. Before going to discuss these specific angles, we have to know what is the measure of angle and how to measure it. The measure of angle means it is the degree of rotation of the rays from its initial position to the next position or final position. Here we discussed that two rays constitute an angle, but actually these are the two positions of the rays. The initial position, from initial position the rays rotates to some degree, and that degree measure of the rotation is measure of angle, and that is usually measured by the protractor as we have in the geometry box. And by that instrument we can measure angle from 0 to 180 degree. When we consider the rotation anti-clockwise, then it is considered to be positive, and when it is in clockwise direction, it is considered to be negative. Now, among these angles, by the amount of rotation or measure of degree measure of the angles, we can name some types of angles. What are they? First is acute angle. What is acute angle? An acute angle measures between 0 degree and 90 degree. Okay? So, it is the measure of angle from 0 degree to 90 degree. So, 1 degree, suppose an angle measures 1 degree, that is an acute angle. 26 degree is an acute angle because it is less than how much? 90 degree. And 76 degree, 89 degree. So, 89 degree also an acute angle. But what is the 90 degree angle? Why it is the marked line? Because when the measure of angle is 90 degree, we say that is a right angle. In this figure, you can see AOB is a right angle because its degree measure is 90 degree. And while marking it, we usually use a symbol like this as it is used in your figure. So, this shows a right angle. And if the measure of angle exceeds 90 degree, what is it called? An angle greater than 90 degree but less than 180 degree is called an obtuse angle. Here BOA or AOB is an obtuse angle because the rotation has exceeded 90 degree. Now, you see, when the rotation comes to in such a position that the initial position and the final position of the rays are completely opposite to each other, then it forms a straight line. So the angle, that is angle between OB and OA rays, is called straight angle, and the amount of this angle is 180 degree. And if this angle measure increases 180 degree, then what happens? Its name will be reflex angle. So an angle which is greater than 180 degree but less than 360 degree is called a reflex angle. While writing a reflex angle, we have to denote its acute or obtuse angle we have to consider. If we say reflex angle AOB, that means it is 360 degree minus angle AOB, because whenever we discuss about an angle, it always comes to our mind that a figure that measures from 0 degree to 180 degree. So if I say it is angle AOB, definitely you will in the first look you will see that it will come to your mind that the value which is less than 180, that is your angle AOB. So when we express the reflex angle, then we have to write that reflex AOB. Simply we cannot write AOB. We have to write reflex AOB. That means 360 degree minus degree measure of angle AOB. Now we have to study some other type of angles, that is complementary angles and supplementary angles. Complementary means what? When the sum of two angles is 90 degree, then we call both the angles are said to be complementary angles to each other. And similarly, if two angles whose sum is 180 degree are called supplementary to each other. By using this definition, we can have many problems from this, such as suppose two angles are complement which are in the ratio 2:1, then find the angles. So in this case, what to do? Suppose the angles are in the ratio 2:1. So the value of angles we can write that 2x and x. 2:1. The angles are in the ratio 2:1. So we can write the values to be 2x and x degree. If they are complementary, then 2x degree plus x degree, that gives 90 degree. That means 3x degree is equal to 90 degree, or x is equal to 90 degree by 3, that is 30 degree. If one angle is 30 degree, then the second angle is 2x, that is 60 degree. Now see, our angles were 2x and x is 30 and 2x is 60 and sum is 90 degree. So 60 degree and 30 degree are complementary to each other. Similarly, we can have many such problems in supplementary also, supplementary angles. Now let's consider adjacent angles. Two angles are said to be adjacent if they have a common vertex a common arm and their non-common arms are on different sides of the common arm. Now look at the figure. Here we have AOD and DBC, two adjacent angles. Here B is the common vertex and BD is the common arm. Now, for which are the uncommon or non-common arms? BA and BC are non-common arms. Where they lie? If we extend BD in direction of B also, then we can have two parts of BD. In one half we have BA and in other half we have BC. So we can say that these arms AB and BC are on different sides of the common arm. Now what is specific about these adjacent angles? Let's see. When two angles are adjacent, then their sum is always equal to the angles formed by the two non-common arms. Here the non-common arms are AB and BC. So the angle formed by non-common arms are ABC and the adjacent angles are angle ABD and angle DBC. So we can write angle ABC is equal to angle ABD plus angle DBC. Here when we are adding the angles, that means what we are adding? Are we adding the figures DBC, DBA, etc.? No, definitely not. What we are adding is the degree measure of these angles. So the degree measure of angle ABC is same as the sum of degree measure of angle ABD and degree measure of angle DBC. In this figure we have also two adjacent angles. Here the non-common arms BA and BC form a line. If the non-common arms BA and BC form a line, then angle ABD and angle DBC are called linear pair of angles. If two lines intersect each other, we have four angles, the vertical opposite angles. The vertically opposite angles formed when two lines AB and CD intersect each other, say at a point O. In this case, we have a pair of vertically opposite angles AOD and BOC. Can you find the other pair? The other pair is angle AOC and angle BOD. If you are asked to draw different lines PQ and RS on a paper, you can draw it in many ways. From those ways, we can categorize it into two ways. What are they? See, as the figures show, we can have these two types of figures. That means the lines PQ and RX will intersect each other, or they will never intersect each other. If they will never intersect each other, then the lines are called non-intersecting lines, and if the lines intersect each other, then they are called intersecting lines. If on a plane the non-intersecting lines are there, if we extend it infinitely and they will never meet, that means the lines are parallel. Why they are parallel? Because the distance between these two lines will always remain same. How to know the distance between them? The lengths of the common perpendiculars at different point on these parallel lines is the same. If we draw a line from a point of PQ to RS, it will also be perpendicular to PQ. Similarly, so this line is called common perpendicular to both PQ and RS. If we draw another perpendicular from another point of PQ on RS, both the length will be the same. So this equal length is called the distance between two parallel lines. Let's find out the relationship between the angles formed when a ray stands on a line. Here in this figure, you can see AB is a line and OC is a ray. Now, what are the angles formed here? Here, the angles formed at O are AOC, BOC and AOB. Then, what is relation between these two? As we know, AOB is the non-common arms of the adjacent angles AOC and BOC. So, AB is a straight line and the angle obtained by the non-common arm is same as the sum of the angles at the adjacent angles. So, you can write angle AOC plus angle BOC is equal to angle AOB. What is the measure of angle AOB? You know, as AB is a straight line, so AOB is a straight angle, means its measure is 180 degree. So we can say that angle AOC plus angle BOC is 180 degree. From this, we can have an axiom. What axiom says? If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. Why it is axiom? Because we cannot prove it logically. By experience, by drawing, we can show that the sum of angle AOC and BOC will be 180 degree. So the axiom says again, if a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degree. Recall that when the sum of two adjacent angles is 180 degree, then they are called a linear pair of angles, as we discussed earlier. Using this, we have some examples, some problems. Let's solve it. If a ray OC stands on a line AB such that ratio of angle AOC and BOC is equal to 7:5, find the measure of each angle. Measure of angle AOC and measure of angle BOC are in the ratio 7:5. we can say that angle AOC is equal to 7x. Let it be. Let angle AOC is 7x and angle BOC is equal to 5x. As we know that angle AOC plus angle BOC is equal to 180 degree. Why? Because a ray is there and a line is there, a ray stands on it, and sum of the angles is 180 degree. So we can say 7x degree and 5x degree. Sum of these two is 180 degree. This means 12x degree is equal to 180 degree. That gives x degree is equal to 180 degree by 12, that is 15 degree. If x is 15 degree, then what is AOC? Then angle AOC is equal to 7 into 15 degree is equal to 105 degree, and angle BOC is equal to 5 into 15, that is 75 degree. Is this answer correct? Let's check it. If we find the sum of these two, this is 180 degree. As we know, AOC plus BOC is equal to 180 degree, and here also 105 degree plus 75 degree is 180 degree. So this answer is correct answer. Let's see another problem. A ray OC stands on a line AB. OP and OQ are bisector of angles AOC and BOC respectively. Find the measure of angle POQ. AOC angle plus angle BOC equal to 180 degree, because they are linear pair as OC stands on line AB. We can say that OP is bisector of angle AOC. This implies now we have two parts of angle AOC, that is angle AOP is equal to angle POC, and both of them are half of angle AOC. Again, OQ is bisector of angle BOC. This implies angle BOQ is equal to angle COQ is equal to half of angle BOC. Now, if we multiply 1 by 2 on both sides here, so we have half of AOC plus half of BOC is equal to half of 180 degree. What is half of AOC? Half of AOC is equal to POC. So angle POC, similarly half of angle BOC is equal to COQ. COQ is equal to 90 degree. Now POC and COQ are two adjacent angles, and their non-common arms are PO and OQ. So angle POQ is equal to 90 degree. So dear students, today we discussed about various definitions of straight lines and angles, different types of angles and pair of angles like adjacent angles, complementary angles, supplementary angles, and we also learned that when a ray stands on a straight line, then the angles so found are linear pair. So dear students, this is the end of the lesson today. Thank you.